So what we need here is before we start adding, subtracting, multiplying, dividing with integers, a lot of students don't understand what integers are. Don't worry, I'm not going to repeat for you. I don't think too much of what you've already learned, but there's a few key points I really need to make sure that you understand, okay? So first thing, do we even know what an integer is? So in order to talk about that, I actually have to back up to a different set of numbers. And I already screwed up. The first set of numbers that we have to talk about are known as the natural or counting numbers. Okay, so obviously we've been using numbers for a really long time in our life. You know, sometime around the time you were about 2 or 3 years old, someone probably set some blocks in front of you or some stuffed animals and asked you to start counting them. And of course, if you were to start counting, you would start with the number 1 and you would go on from there. 1, 2, 3, the numbers that we know about. And you got to think about this, like, when does this list stop? 1, 2, 3, when are we not able to count anymore? Well, as you know, that list goes on and on forever. We could count for forever. The only thing stopping us is the time or the desire, okay? And so those are known as your natural or counting numbers, okay? Now, these are very useful when you're little, but at some point you realize that there's got to be a way to say that I have nothing. I have nothing to count, or I have no blocks, or I have no ball. And so we need a number for that. And so the day we got the number 0, that when you add 0 to the set of natural numbers, we call that the whole numbers. So it's the same exact set, but now it has 0 in it. So 0, 1, 2, 3, going on and on forever. So those are the whole numbers. Wonderful. Now, this is pretty much what you deal with in, you know, your elementary math days, okay? It's not until we get to integers that we start seeing this new idea. And this new idea is opposites of numbers. So integers are defined as the set of whole numbers. So those numbers we just wrote above, 0, 1, 2, 3. But it's the set of whole numbers and their opposites. And I promise you, I'm not just going to talk and talk and talk at you. I really, really have an application of this that you need to understand. So integers are the set of whole numbers and their opposites. Now, I really should have been putting all these numbers in set notation. In math, when we want to say a set, that's like up there, the natural counting numbers is the set of all numbers, 1, 2, 3. The set of whole numbers. So I'm going to do that here. I'm going to do a set. Now let's think about these whole numbers go on and on forever, getting greater and greater and greater, like we talked about before. But the opposites of those, if I say, well, what is the opposite of 1? Well, of course, the opposite of 1 is -1. I just hesitated because I'm like, well, why didn't I say opposite of 0? And of course, I didn't say opposite of 0 because there is no opposite of 0, but there's an opposite of 1, it's -1. There's an opposite of 2, it's -2. And an opposite of 3 is -3, and so on and so forth. And if you think about it, negative numbers go on forever and ever, getting smaller and smaller. Does that make sense? I hope it makes sense. It's a little weird to be talking and not hearing a response, but I see you. Wonderful. Okay, so the set of whole numbers and their opposites. Great. So yes, isn't the number line helpful? And I'm definitely going to be looking at that. But before I do, I want to talk language. And this is what I want to say to you. When I asked you in words, what is the opposite? I have never yet had a student, when I asked what is the opposite of 1, not be able to tell me what the opposite of 1 is. And I'm sure you're probably not different on that. If the opposite of 1 is -1. And so this idea is if the opposite of 1 is -1, that means I can read a negative sign as the opposite. So yes, I can read this number that I see here as -1, but I can also read it as the opposite of 1. And this is actually a crucial concept that's going to come up a lot. Anytime you see a free floating negative sign that doesn't make sense to you and that screws you up in a math problem, try replacing the negative sign with the word opposite in your head. Like, say it out loud. Oh, the opposite. And that'll make it make a lot more sense. Let me show you what I mean. Let's get out some typical problems here. So for example, you might see something that looks like this. If you see a problem like this, a lot of students are going, am I supposed to multiply? What am I supposed to do? That is one way to think of it, but I think the simplest way to think of this problem, because the parentheses, all they're doing is setting apart the negative from the 8. The easiest way to think of this problem is just, what is the opposite of 8? So, of course, what is the opposite of 8? Brilliant. And so that is where it comes up when we start talking about the opposite of an opposite. And I really want to bring this up because this is almost always on the first 5 problems of the GED, the ones where you don't get a calculator. So you don't get a calculator, and students panic at the sight of a negative, and they'll often do things that end up with 2 negatives in a row. So you might see this as a part of a problem. And students lose their minds. They're not sure what to do. Now, you've probably figured out by now what to do, but I just want to show you how it flows out of this, because I'm looking at the opposite of -8. Well, of course, you know, if I take an opposite twice, I end up right back at the same place where I started. The opposite of an opposite, exactly, takes me right back to +8. And notice that I didn't bother to put a +8. Now, I could have. This is exactly the same. Let me not write it like that. This is exactly the same as plus or +8, but you'll never see a math teacher do this because we're so lazy. We'll just write plain old 8, right, instead of +8. Okay, great. So this actually comes up all the time in math applications. So what I wanted to look at with you was just a few applications of this on the GED itself, okay? So one application of this concept. If you've been doing any addition and subtraction problems with negative numbers, you've found out that sometimes this weird thing happens where you have like minus a negative number. Have you seen anything like that where we have a number minus a negative number? Yeah, and students just do not know what to do. But again, if you just read that sign like opposite, it won't stress you out. When I look at this right here, I totally read this phrase as the opposite of minusing 5, or the opposite of -5. And of course, we know that the opposite of that is +5. And so I've just replaced that whole pesky statement that I didn't like with a +5, dropped my 7 down, and now the math is super easy to do. Is that nice? Is that cool? I'm looking to see if you've got a question. You see, now that is an interesting thing. I love this. Okay, so the question I have here, for if anyone can't see the chat window, is I thought parentheses meant multiply. And so I actually, if you were in my GED class, I would scold your old teachers for teaching you that parentheses mean multiply. It's not that they never do. It's that parentheses are a really versatile thing in mathematics. We use them for different things. Okay, so sometimes we'll use parentheses for grouping. We hear about them in the order of operations a lot. Sometimes we'll use them to separate 2 numbers that are multiplying. And what we're usually using parentheses for is to kind of separate things that we need visually separated so we can make sense of them. Let me show you what I mean. So great question. Now, by the way, I have seen teachers who also teach this when you're looking at this right here as an act of multiplication, why it goes there. And so if you ever have a teacher teach you that way, they're not wrong, okay? There's oftentimes lots of different ways to visualize different math. So I don't want you to panic like, oh, if I learn this as, if I learn this as like some teachers will come in here and say, oh, there's really an imaginary one here, and they'll multiply it through, and that does work as well, okay? If you've never heard that, just ignore that I ever said it. But I just want to show you real quick with the parentheses because that's such a good question. So, okay, I'm going to give you 3 problems with parentheses, only one of which has multiplication, okay? Okay, so can you see that? Okay. So only one of these is using parentheses to mean multiply, like explicitly. Only one of these problems has 2 numbers multiplying. And it's the 5, exactly, yes, the first one. It's the 5 times, whoa. I don't know how to get rid of this. Oh, close. Okay, so it's this one, the 5 times 3. And the reason why this one is multiplication and the others aren't is the proximity issue. It's not, multiplication isn't really about the parentheses. I know that a lot of times that we have parentheses there, but it's really about proximity. So proximity is a word that means closeness. See how the 5 is all shoved up against the 3 like that with nothing in between them except a parentheses? Because they're all tight like that, we don't see a symbol between them. They're multiplying. I mean, it's like I'm saying, oh, I have 5 3s. I have 5 3s. Okay. In fact, mathematicians are so lazy that when it's not 2 numbers, like if it was a number and a letter, like 5 and A that I wanted to multiply, I would just shove it together like that. I wouldn't even put a symbol there. 5 times A. Okay, when we just want to say multiplication, we just put things really close with nothing in between them. We know they're multiplying. It's about proximity. Okay, so you might say, well, why don't we just write this? Why don't we just write 5 times 3 like this? Well, you can see the second I do why we don't. And it's just because of a weakness in our numbering system. If I wrote 5 times 3 like that, it wouldn't be 15, it'd be 53. Now, and that's because of just the way our numbering system works, our digit system. And so because of that, we'll just go, okay, well, I'll just put little parentheses between them. And so you can tell a 5 from a 3 and not mistake it for 53 and multiply. So again, the multiplication is not really about the parentheses, it's more about the proximity. Does that make sense? Good. And you can see that anytime we want to set something apart, we'll use parentheses. That's what they're really for. So in this particular multiplication case, I was trying to set apart a 5 and a 3 so you wouldn't mistake them from each other. In this next problem, I use parentheses to set apart a grouping. Some work that I would like you to complete first. I've taken a mathematical operation, I've enclosed it in parentheses to give you a sense of priority, to tell you what to do first. Does that make sense? Well, the good news is the lesson that I'm teaching at 4:30 today is on order of operations, which I will go into that very concept in more detail, okay? And I'll be recording that one. So for now, I'm going to just leave that right there. I like it though. You're like, kinda. Okay, so now the next one, again, I'm using parentheses, but here I'm using parentheses to just set apart the minus and the negative sign because it's just a little visually confusing. But I have to tell you that that's only there for visual reasons. It doesn't have to be there. I could just as easily write this. 3 minus negative 3. Those parentheses are, like I said, only there to make things less visually confusing. They're not even necessary. This is a subtraction problem at the moment. Does that make sense? Wonderful. Okay, cool. So good question about parentheses. Okay, let's get back to our integers topic. Okay, so there's something cool that happens the day you get integers. So basically when we get integers, when we get negative numbers popping up, we need a new operation. We know that there are certain times in life where negative numbers don't make sense. Okay, so when we get integers, we need a new operation. Let me show you what I mean. So first of all, if you haven't, it's kind of hard when you're in my online class because you don't get all your math from me, you get some of it somewhere else. So if I use the word operation, do you even know what I'm talking about when I say operation? Looking for an answer here. Interesting. Okay, sums are one kind of operation, finding the sum. So that's a sum involves an operation, the operation of addition. But there's lots of operations in math class. There's adding, subtracting, right? Adding and subtracting. Um, Basically, yeah, what we're doing with numbers are the operations. Multiplying, dividing, raising to powers, and rooting are a bunch of different operations, probably the first six most students learn. But the day we get absolute value, we need a new operation. I'm sorry, the day we get integers, we need a new operation. And that operation is called absolute value. Now, I'll tell you what the definition of absolute value is, but I'm going to tell you, bear with me because it's actually a really, really simple operation. So absolute value is defined as a number's distance from zero on the number line. And hopefully you saw this. Have you seen this? Good. Of all the things that Odyssey Ware went over or that you've seen in your math so far, this is one of the GED favorites. They love absolute value application problems. They're almost always on the first five problems of the GED where you don't get a calculator. So you really got to understand this. So a number's distance from zero on the number line. Of course, now there was no reason for absolute value back in the time before negative numbers because it's really silly to talk about the absolute value of 5. How far is 5 from 0 on a number line? What a silly question. We call him 5 because he's only 5 away from 0. That's why the name is 5. But the second we get to negative numbers, it suddenly makes sense. This operation actually does something. It gets a little more exciting. Because if I want to talk about how far is negative 5 from 0 on a number line, see that language I'm using, that how far? It's a measure of distance. And distance cannot be negative. And I say that again. Distance cannot be negative. Of course it can't be negative. I want you to imagine that I asked you, how far did you walk to the store? And you tell me I walked negative 5 miles. Now, I don't care if you walked north or south or east or west. You did not walk negative 5 miles. You got in your 5 miles, okay? Are you like gaining calories if you walk negative miles? It just doesn't even make sense, okay? Even if you walk backwards, yeah. And so distance is always positive. And so when you take the absolute value, oh, okay, so they had problems like that? Wonderful. I didn't see that particular problem, probably because you didn't get it wrong. You got it right. I'm looking at all the ones you got wrong. So great. Yes, we get that 5 here. But I just want to show you how that's going to look on the GED. Okay, so here's some example problems where this concept is going to come up on the GED, okay? Let's get to the simplest example first. We are doing straight up GED example. Okay, so very, very frequently, they will have that number line, like I said, in the first 5 problems. I'm screwing stuff up. I'm still learning how to use this tablet, can you tell? They bought me a nice new tablet so I could be a good teacher, and we'll see if it works out. Okay, so they'll have these problems that have a number line, let's say 4, negative 4, and then it'll have some points labeled. And then the question will ask something like, how far is the point from the number line. They'll give you a specific point, but I want to practice a few times. So I'm sorry, I just misspoke again. How far is the point from 0 on the number line? So hopefully these came up. I know they did. I saw you guys working some of them. Exactly right. So then you should be able to really quickly tell me how far all these points are from 0 on the number line. Notice that they don't use the word absolute value, but we know the definition of absolute value. So whether it looks like it or not, this is an absolute value problem because they asked me this wording here. How far, the distance. Okay, so you tell me, how far is point A from 0 on this number line? Oh, she gave me all the answers, y'all. Okay, so Bianca says point A is 4 away. I absolutely agree. Now, point B is over here. So I can, yeah, it's all good. But here's the big issue. Remember that distance has to be positive. So I can see that. But still, even if you're doing it that way, distance is always positive. Even though point B is at -1, it's not -1 away from 0 because distance is always positive. Point B is actually 1 away from 0. And this is a really, really common misconception of students. I'm not asking you what is the name of the point. The point is -1. Yeah. Yay, it makes so much sense. Okay, cool. So that's the idea with absolute value. It takes away negativity, and that's it. That's all that operation does. It just takes away negativity because sometimes in life things aren't negative, like in the case of distance. Okay, so cool. So then when we look at point C, you absolutely saw that point C was 2 away from 0, but then you just tell me how far away from 0 is point D? Absolutely. There we go. And so this is why they love to put this in the first 5 questions of the GED, because our instinct will be just to name the point, make it negative, and we'll get it wrong because they didn't ask us to name the point. They asked us just how far away is it? Absolute value. Okay. So very cool. Now, they'll make this problem even trickier. So let's look at an even trickier example of this problem, okay? So again, I'm doing another GED example. I've spent a whole lot of time teaching GED, and I know they love these tricks. Oh my gosh. So here's another trick of theirs. Again, we'll have a number line. It'll look almost the same here. It'll have a few points. And it'll be asking you the exact same question. Again, I would like to ask you, how far is each point from 0 on the number line? And students tell me all the time that this is the exact same problem as the last one, and they don't see the difference. In fact, the most common answer I get when I ask how far is point A from 0 on this number line, so they'll tell me, oh, it's definitely 1. Oh yeah, I know it's 1. It makes me giggle every time because I'm like, well, here's point A right here, and there's the number 1 over here. How could point A be on 1? Okay, so I want you to watch out for this trick. They don't have to count by ones. They don't have to. They can count by 2s, they can count by 5s, they could count by 20s. They could count by 167 if they really wanted to, okay? We have no guarantee of what they're counting by. And here, they're being even ruder because they're counting by pieces that are smaller than 1. Can you see that? We have multiple pieces from 0 to 1. They are counting by some kind of fraction, pieces and parts. And so students will panic, they'll lose their mind, I can't do fractions. And I'm like, every student I know can count the number of pieces. So help me out here. Let us count the number of pieces that we see here between 0 and 1. So I'm looking at this one whole thing, and I want to know how many pieces it's broken into. Looks like it's broken into 1, 2, 3 pieces. Can you see that? From 0 to 1, I've got 3 pieces. Okay. When you break one whole thing into 3 pieces, you just broke it into thirds. Ah, exactly. Just like when we're at zero normally, we don't count one until we move. You don't count one until you move from wherever you're starting. Does that make sense? Okay, cool. So yeah, I started here and I counted 1, 2, 3. Okay, I'm not counting dashes, I'm counting like pieces, so that chunk. Okay, so cool. So I'm broken into thirds here. And so, yes, exactly. Point A is 1/3 away. And when you say 2/3, I'm not sure if you're talking about point B, C, or D. Point D is definitely 2/3 away. And so then how about point B, which is the one they'll probably do because they want to combine negatives and fractions on you? Yes, exactly. If I count point B, again, I'll start at 0, and I just moved 1/3 over that way, 1 out of 3. And then if I were to count here, 1, 2 out of 3, exactly. That's also 2/3 away. And see what snots they are? I mean, combining fractions with negatives, with absolute value, with number lines, all kinds of things going on. But you did it really well. Cool. Okay. So I'm going to give you one more. Example that would be just like that. Okay, let's take a look at another one. Oh, so distance, so all are positive numbers. Yes, absolutely, exactly right. Anytime I ask you about distance, the answer will be positive, irregardless of where the number is positioned. Okay. In fact, if you take away nothing else from this lecture, take that away, because they will not necessarily use the word absolute value. They won't necessarily have negative numbers. They won't necessarily have a number line, but they will put this word, just slip in how far, or just slip in a distance. They're going to expect you to know that whatever answer you get is going to be positive. Okay. So here's another great example of how they might do that. They might give you a couple points on a number line. And then they might say to you something like, what is the distance between points A and B? So this isn't exactly an absolute value question. Oh, between points, oh my goodness, A and B. This isn't exactly an absolute value problem because I'm not asking you how far is A from 0, how far is B from 0, but by doing the absolute value, it's going to be really easy to see, okay? I cannot figure out how to change the, oh, there it is, color, yay, I'm getting smarter. Yes, I use the word distance, exactly. So I know my answer has to be positive. Okay, I'm saying it's not exactly synonymous to absolute value because absolute value is distance from 0. I say that again. Absolute value is distance from 0. So absolute value is a kind of distance. Yeah, okay, cool. So, but I'm actually going to use the absolute value to solve this problem because you know what I see? I see that if I could just break it at 0, there are 2 spaces between A and B. There's the space from 0 to B, and there's the space from 0 to A. Both of those are in between A and B. So if you think about it, the distance is those 2 spaces put together. Does that make sense? Not sure? Let me keep talking and we'll see if it makes sense, okay? So let's look at the distance from 0 to point B. We already know that point B is 4.25. And so how far away is B from 0? Of course, B is just 4.25 away from 0, which makes sense. And that is B's absolute value if you think about it. That's how far B is away from 0. A has the same thing going on. How far away is A from 0? Well, A is exactly 3.7 away from 0. And if you think about it, that's A's absolute value. Now, if I want the distance between A and B, since they're on either side of 0, I could just combine these 2 numbers. If I subtract these 2 numbers that I've written down right now, I will get a very small number. It will be less than 1. We can see that these two numbers are much further apart. And so what I'm actually going to end up doing, I have this piece and I have that piece. Do you hear that and language? I have this piece and, okay, I need to put them together. I need to total them. I have two separate pieces. Because I have them as both positive, as I total them, they're going to add up to the total distance between here. And so I'm going to add them up. Did I really write 4.25? Oh, I see what I did. Can you see what I did? I'm an idiot. I wrote 4.5 over here. Yeah, that was 4.2. Sorry, I mixed up my 4.2 with my 5. So, but anyway, 3.7 and 4.2. Why am I not writing? Will give me 7.9. And I can see the distance between the two is 7.9. Yeah, you had it long before I did. Okay, so glorious. So now you're probably thinking, Kate, I know something. I know that if I wanted to find the distance between two numbers, I would actually need to subtract, which is probably why you said subtract to me. It's like, no matter what your diagram looks like, Kate, when we try to find the space between two things, we usually subtract, you know? And let me show you how we really did subtract, whether you realize it or not, okay? So I'm going to take this exact same number line and I want to show you something kind of cool. You're like, Kate, we did not subtract, we added right there. I see that addition. Let me show you. Okay, so busting back out that number line. And this time I would like to get some numbers that make a little more sense to us. So you can see what I mean. I want to get some just nice, easy numbers going on here. So if I were to ask you, like, how far is it from point A to point B? What is the distance between point A and point B? That would be super easy for you. You would tell me what? Ah, I disagree. Yeah, there we go. Okay, cool. So definitely the difference between it's all good. Between point A and point B is 2. Because I could just count 1, 2. There's 2 spaces between them. Super nice. Now let's think about how we would do that mathematically. How could I take the numbers 1 and 3 and get this number of 2? Of course, what would the math? Oh, okay. Okay, let's just pause. And let me know when you're coming back. Okay, so I totally agree that if I were just taking 2 numbers, like the number 3 and the number 1, and I wanted to find their distance away from each other, that I could subtract. That would work. You can see that those 2 are 2 apart. But I have a question for you. How would I have to subtract these in order to get an answer that makes sense? Take a look at this. If I were to just subtract them the way I see them, like point A and point B, the distance between A and B, and I were to subtract them this way, 1 minus 3, what would I get if I did the problem this way? I should get 2, but I'm not gonna get 2. If I have only 1 and I take away 3, I just took away more than I had. And so I'm going to end up, I mean, it's a difference of 2, but I'm going to end up in the hole. I'm going to end up at -2. I only had 1. It's like I had $1 in my pocket, and then I went and spent 3. Can you see how that math doesn't really work? Okay, so there's a couple ways I could do it. A couple ways that I can do it to make sure, because I know distance has to be positive. I know it has to be positive. Now, I could just flip the order if I wanted to. You know, I could do B minus A. I could make sure that the larger number comes first. Three minus 1 will be 2. And so I could do that. But sometimes in algebra, we won't always know which one's the larger number, especially if I'm calling the 2 numbers X and Y. I won't always know which one's the larger number. So I need an operation that turns all things positive. And I told you we do have an operation that turns all things positive. So I want you to imagine that I had two numbers that I just didn't even know what they were. So like maybe they're X and they're Y. Now I want to find the distance between X and Y on a number line. Well, I know I can just subtract, but I have to make sure that my answer is going to be positive. And I can't make sure that they're going to be positive by making sure that the larger one comes first, because I don't know which one's larger. How am I supposed to know which one's larger? Could be X, could be Y. And so that is why we need that operation of absolute value. And so what I could do is I could just take the absolute value of this entire expression, and that would make sure that whatever answer I got, whether I got a negative or a positive number, in the end, I would just say, oh, it's just positive. It's just 2 apart, or it's 20 apart, or in this case, it's just X minus Y apart. So I know that this is kind of tricky because you're going, oh my gosh, algebra? But don't worry, I'm not trying to throw the algebra. You don't need to memorize this. What I need you to realize this is that one foolproof way to find distance you can subtract those two numbers. And again, this is to find distance between 2 points on a number line. But then of whatever answer you get, you would have to take the absolute value to make sure that your answer would be positive, because we said distance is always positive. Okay, and so I'll show you this example. That's pretty typical GED. They would have a number line. It would not be labeled. You would not necessarily know these points. And they would say, write an expression that represents the distance from point A to point B. And again, we're on a number line. And then if they gave you this, again, it would be on the first 5 problems of the GED where you don't have a calculator, but who cares if you don't have a calculator? There's no numbers to deal with. I mean, what would I even do with a calculator here? Okay. But the good news is this would be a multiple choice problem. So you wouldn't have to remember this off the top of your head. You would just have to recognize a right answer when you saw it. And math teachers in general, not just the GED, are pretty predictable. We know what fools you guys. So the answers would probably look like this. There would be an A minus B, an A plus B, an absolute value of A minus B, and an absolute value of A plus B. And so we have to know that there's 2 things to distance. Yes, exactly. There's 2 parts to distance. You can just subtract the 2 numbers the way they stand, subtract the 2 numbers the way they stand, and take the absolute value. So you're absolutely right. We would subtract the 2 numbers. And then once we were done subtracting, we would just make sure our answer was positive, because distance is always positive. So I'm glad that one makes sense to you, because that's about as tricky as it gets on the GED. Is that good? Yes, we're good. Oh, I'm saying I'm glad this one makes sense to you, because this is about as tricky as it gets on the GED. This is as hard as you're going to see this absolute value get. No numbers. We got letters going on. So are you good with this question? Okay, wonderful. So then I now want to show you how that original problem I did actually turns out to be exactly this. So let me just show you, because remember that one problem where you were saying, I would subtract, and I said, well, I added, and you said, shouldn't we subtract? So let's take a look to show you how your way and my way could both work here. So I don't remember exactly what the points were, but I had like negative 3.8 and maybe positive 4.5. It was something like that. And I wanted you to find the distance between these 2 points. And we actually did it in a different way last time. Last time, instead of just going straight to the exactly, because we didn't find the distance between the 2 points. Instead, what did we do? We found the distance from here to here. Just that piece. And then we found the distance from here to here. We found 2 different distances. And then, because I could see visually that those 2 distances are being put together, I just added them up. So that was one way to visualize this. And if I were to do this, 8 plus 5 is 13, carry the 1, I'd get 8.3. This is definitely a different problem. I didn't have to carry last time. But anyway, it was something like this, okay? So that was one way to do this. I took the two different distances and put them together. Does that make sense? Cool. Now let's look at it. If we could, you say, Kate, you told me that I can always find the difference between two numbers by subtracting and taking the absolute value. Okay. So I'm going to show you that I could have done it the other way as well. I could have taken these two numbers. Now, what are these two numbers? The first number that I see is negative 3.8. Are you cool with that? The second number that I see is 4.5. Now, we said if we were going to just go straight to finding the distance between these two, we would have to minus. So I'd get negative 3.8 minus 4.5. So we're cool with that, right? But then we said after we minus the two numbers, that whatever answer we got, we would have to make positive. Now, how a mathematician expresses that they're going to make an answer positive is they take the entire problem and they enclose it in absolute value signs. Are you cool with this expression right now? I'm saying I'm going to subtract these two numbers, and then I'm going to make my answer positive. Make sense? I'm worried because I'm not hearing from you. Yeah. So you don't have to do the math yet, so don't stress on that. But can you see that I subtracted the two numbers? Can you see the subtract sign yet? So I just wrote the first number exactly the way I saw it with the minus sign. And I subtracted the second number exactly the way I saw it. Does that part make sense? Okay, cool. Now, all I'm saying when I add the absolute value bar signs is I'm just promising to everyone that no matter what answer I get, I'll turn it into a positive because it's a distance problem. So that's all I'm saying, but I'm saying it in mathematical talk instead of saying it in words. That's a struggle to students when I say it in symbols. But are you cool with what I'm saying mathematically now? I'm not done yet. Don't do the answer yet. You're getting yourself in trouble. Are you okay with my writing? Okay, great. Okay, now let's actually do the work. Okay, so your mistake is that you don't know how to subtract with negative numbers. So that's what's throwing you. Now, the good news is if I actually had this particular problem just like this, if it was written out like this on the GED, I'd probably have a calculator. But if I were doing this number line example, I might not have a calculator. So how could I deal with something like this? Now, I already tell you that if I didn't have a calculator, I think that's the easier way. I did it a different way and I'm going to get the same answer over here, okay? But I just want to prove to you that this is the same math. It really does work, okay? So let's take a look here. The deal with negative 3.8 is that you're already in debt. It's like you're in debt $3.80. I know, especially if you're an adult girl, you have bounced your account before. Those fees come down, something happens, and you end up in the hole, right? I was a single mom for 14 years. I have been negative in my account. Yeah, so you hear me. So I want you to imagine that your account was already in the negative, $3.80, and then another charge happened, a negative $4.50 charge. Think about the way life works. You're already in the hole. You go negative some more. What happens? You're really, really in the hole now. Now you're in big trouble. Exactly. If I'm already negative and I go more negative, it adds up, doesn't it? I would, in fact, be in the hole a whole lot of money. 8.3. That's what would happen when I subtracted those two numbers. I just went in the same direction twice, so it added up. I was already negative and I went more negative. Okay, now, but I promised you up here, I promised you that after I subtracted, I would take the absolute value. So I still need to take the absolute value of this number because I wasn't really doing money. I was really doing distance. And you and I know that distance is always positive. So got negative 8.3, but I'm going to call it positive 8.3 because it was a distance problem. Okay. Look at that. Good math always works. Now, I have to say, I think the right is more confusing, where I just subtract the two numbers on the number line and I find the absolute value. It's more confusing for most students. Most students have an easier time taking the distance from here to here, the absolute value, and the distance from here to here, the absolute value, and then just putting the two together. Okay, so I don't care which way you do it, they both work. Which way makes the most sense to you? Shoot, then do it that way. Just know why you're doing what you're doing, okay? I'm waiting for a response. We good? Are we good with this problem? Me too. Me too. But this actually happens all the time. And students don't realize it. I'm going to show you. Oh, here's a great example. Here's a great example problem. You ready? Okay. So I don't run out of example problems, do I? Let's look at this other one that always tricks students, okay? They'll say the average January temperature in Honolulu, Hawaii. Don't we wish we were in Hawaii, right? Is, I don't know, probably like 68 degrees. So lucky. Okay. And then they'll tell you like the average January temperature in Fairbanks, Alaska. Is, I don't know, something nice and nasty. Let's pretend like it's negative 25 degrees. Gross. And then they'll ask you to find the difference between the two average temperatures. Now I have to tell you, most students do it wrong. So I'm going to grab my wrong color. Let's grab our red pen. We're all scarred from red pens, right? Okay, so most students go, oh, it's a difference problem. Difference. I've got to subtract. That's not the wrong part. That's actually true. You could subtract. It's perfectly legit. Okay, but then what they do is they go, okay, 68 minus 25. And then they subtract and they tell me 43 degrees. And I'm like, you're a liar. There is not only 43 degrees between Hawaii and Alaska in January. I've lived in both those places, and I tell you, it's a whole lot more than 43 degrees that differs the two. Okay, so if you were to think about it on a thermometer, though, which is just you could. It actually doesn't matter what goes first. What matters is that you make your answer positive. But hold on one second, because I'm going to look at it, because you told me you liked the adding before, right? So I'm going to just show you how you could think of it the way you did the last one, okay? If you think about a thermometer is like a number line that goes up and down. It's got a 0 here. Positive temperatures are up here above it. Negative temperatures are below 0. Does this thermometer diagram make sense to you? Yeah, exactly. That's what a thermometer is. It's a number line just going up and down. And so if you think about it, the distance between, or the difference between 68 and 0, this piece would be 68. And the difference or distance between 0 and negative 25 would be another 25. We had a 68 difference and a 25 difference. Even though the wording says subtract, the one way you could solve this problem is add. Now, I know you're mad at me, so let me show you how it's a subtraction problem as well. 8 plus 5 is 13. 6 plus 2 is 83. 6 plus 2 is 8, so we got 83. Pretend like I'm speaking English, Bianca, and that I'm making sense. 6 plus 2 is 8. Carry the 1 is 9. Yeah, no, I didn't. Good. Keep me on my toes. Keep me on my toes. So 93-degree difference. Now that makes more sense. Okay. There's definitely a 93-degree difference between Hawaii, where you can go to the beach in the summertime, and Alaska, where you're freezing your tail off. Okay. Big difference. Okay. So how in the world could a difference problem, which we know means subtraction, also be an addition problem? So Um, Here's how. Remember I told you this student went wrong when they did 68 minus 25? You wondered if it was a question of order. It wasn't a question of order. It was the problem with their minus sign. They did not subtract. They think they subtracted because of this minus, but this number here was not a 25, it was a negative 25. So if you wanted to do 68 minus negative 25, you sure could. Now that is the difference between 68 and negative 25. Can you see that? The difference between 68 and negative 25? I'm not asking you to do the math. Don't worry about doing the math, but can you see my problem where? Yes, exactly. Yes, and we have come full circle. You brilliant. Bianca says it looks like what is the opposite of negative 25, and you're exactly right. That's exactly why I started with the lecture with that way. Anytime you see an extra negative sign where it looks like you have too many, you don't just drop one, you realize that the opposite of minusing or the opposite of negativity, either way you think of it, is still positivity. And those two minuses become a plus. And of course, subtracting a negative number actually turns into addition because of that wonderful opposite property. Does that make sense? Cool, yay. And then we would see, of course, we'd get the same answer because good math always works. Okay, so whether you subtract it because you're used to a difference, or you draw yourself a diagram so you can see it really turns into addition in the end, you're still going to end up with the same answer as long as you don't drop any information. Okay, so you did brilliant, and we did lots of hard problems, pretty much all the hardest negative problems. And so because these are all the hardest ones, these are the ones that are usually on the GED because they know students forget them. Okay, so do you want me to send you some worksheets about these concepts that you can practice? I think I'll stop the recording now, actually, for everybody else. If anybody wants worksheets, let me know. But